Hello everyone. Welcome to the solution of LeetCode problem 515 named Find Largest Value in Each Tree Row. In this problem, we are given the root of a binary tree and we have to return an array of the largest value in each row of the tree. So here, let's consider this example. The root is 1, which has two children, 3 and 2. And 3 also has two children, 5 and 3. 2 has one children, which is 9. So here, the maximum value of the first row is 1. The maximum value of the second row is 3. The maximum value of the third row is 9. So we have to return 1, 3, and 9. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken this example. Now, the root of this tree is 5, which has two children, 3 and 6. And 3 has two children, 1 and 2. 2 has two children, 1 and 4. Now here, we have to find the largest value in each row. So for the largest value for the first row is 5. The largest value for the second row is 6. The largest value of the third row is 2. The largest value of the fourth row is 4. So we have to return 5, 6, 2, and 4. Now, how can we solve this problem? Here, basically, we have to find the largest value in each of the level. And if any of the problem we have to deal with the level, we will try to solve this problem by using the BFS technology. So here, we will use the breadth first search technique to solve this problem. Now, the breadth first search technique uses the queue data structure. So we are taking a queue. Now, initially, our search or iteration starts from the root. So we have to insert 5 into the queue. Now, this node 5 is for the first level. So we have to insert it into a, let's say, vector, or we don't need actually a vector here. Let's take a variable. Here we have only one value. So 5 is the maximum. So here we have to insert 5. Now we have to remove 5 from the queue. So here 5 has two children, 3 and 6. So we have to insert both of them into the queue. Now the first level iteration is completed. It is the second level. So here our top element of the queue is 3. So we have to remove 3 from the queue. And let's consider it here. And 3 has two children, 1 and 2. So we have to add them into the queue. Now our top element of the queue is 6. So we have to add 6 here. And 6 does not have any of the left or right children. So we don't have to add anything in the queue. Now let's see what is the maximum value between these 3 and 6. The maximum value is 6. So we have to remove 6 as well. So far, we have completed iteration in the 2 of the level and we have found 5 and 6. Now our top element of the queue is 1. It does not have any of the left or right children. So we don't have to append anything into the queue here. So we have to remove it. Now our top element of the queue is 2. It has a left and the right children, which is 1 and 4. Now we have to add it into the queue and remove 2. Now the third level value is 1 and 2. So here the maximum will be 2. Now we are at the final level 1 and 4. The top element is 1. So we have to add 1 here. And the top element is 4. We have to add 4 here. And none of the 1 and 4 has the children, so we don't have to add anything into the queue. So what is the maximum between 1 and 4? It will be 4. So here we have found the value 5, 6, 2, and 4. This is the maximum value in each of the level. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named largest values, which has a root as a parameter. Now we are taking a vector to store the answer. Now here, if root is null, we have to return answer. Otherwise, we have to take a queue which store the tree node and insert the root into the queue. Now we are running this loop until the queue is become empty. And in each iteration, we are calculating the queue size and initializing a variable mx to integer minimum. Now, we are running this inner loop while the queue of size is not equal to 0, and we are storing the front element of the queue into a variable x, and we are removing it. We are updating the maximum, which will be the maximum of maximum and the value of the x, or the value of the front element of the queue. Now, if the front element of the queue has the left subtree, we have to add the left node to the queue. Similarly, if it has the right subtree, we have to add the right tree to the queue. Now here, we have to insert the maximum value we have found for each of the label to the answer vector, and finally return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.